Hi.
Hello.
Hello.
Hey.
I'm so glad. Alex, you're alive. You didn't burn to death.
Yeah, I'm. Hopefully, there's no more explosions or whatever.
Explosion. Yeah. Something happened on the 7th floor.
Yeah, there was a fire, I believe.
Well, like
or
a
at least
real
a fire alarm. I don't know.
Okay.
It doesn't see the fire department showed up, but it ended very quickly. So I'm guessing it was, or maybe one of those little lab fires. I don't know.
Yeah.
Okay, I have my stuff ready. I'm just gonna go to the washroom real quick, and I'll be right back, and we can get started.
Awesome.
Slim, can you share the link first in chat?
Oh yeah, I'll do that.
This would get
so we have some hands-on parts of the lab of the presentation, and if you want to follow along, then you can just follow this hack MD.
Nice.
And that should have the data and code that we use throughout the presentation. If you want to use it for future reference, I'll also talk about it when we start the presentation. But if you want to get a head start, then it's all there.
Cool. Okay.
I'll be back.
Give you a little bit. Yeah.
Yeah, so if they want, they can open that document and give it a quick perusal. To most of the stuff you should be able to kind of download and get running, in 5 minutes, but there's always issues. So you can give it a shot now. We're also going to take a 10-minute break at the midpoint. So that will also be an opportunity for people to refer back to that document or ask questions and try and set up if they want to follow along. You can also just watch this like you're watching a cooking show.
Nice. I'm pretty excited because BIDS and BIDS apps gotta be one of my favorite topics. I think always an exciting feature for a lot of people and good for all of BrainHack.
It's very useful, especially if you're, for anybody in the audience who's just starting, you're in a golden age of data reuse and interfacing with different pipelines. I'm sure, especially Aaron, you probably have some great stories of some terribly managed data sets.
Yeah, I remember the pre-BIDS years, and I was when I heard about BIDS and I realized the power of BIDS apps, especially, I was like, I'm gonna run all the things. I'm gonna be able to run all the things. I'm so excited. So BIDS is something that's been pushed in the general neuroimaging community, but definitely in the BrainHack community for a while. And has kind of taken over the open science community because it's really a success. Like the specification in general is like a success story of collaborative neuroscience research, I have to say, in terms of making a lot of people happy and getting a lot of people to adopt it in a pretty small amount of time. And it affects everything from the way we run pipelines to the way we share and organize our data. And we've been plugging pretty much BIDS and BIDS apps for the entire day because people end up speaking to how it changed their workflows. So without further ado, I have to thank Slim is a research analyst in our group who's been working with MRI and such for a long time, and also is an amazing coder. And one day will leave us to develop video games. So if there's any video game developing companies in the background, let us know. Because we're super appreciative of everything he does. And Alex, who you saw recently, Alex Barton is a research method specialist or MRI specialist working in the Crumble Center for Neuroinformatics, helping with their neuroinformatics platform and especially the way that MR and imaging research is organized across the hospital. And without further ado, I'm going to step back because I'm pretty excited about the session that they've prepared.
Cool. And yeah, thanks for the great introduction. Like you said, there's been like quite a bit of hype around this presentation. I've heard a lot of people like talking about BIDS throughout the day. So I hope we show you how great BIDS is. And yeah, let's get started. Thanks for everyone joining us. Today we will be talking about BIDS and BIDS apps. Like Aaron mentioned, I'm Salim and I'm joined by Alex, and we work with data a lot at CAMH. And we want to share our excitement of why BIDS is just so important on our day-to-day and why I think you should try adopt it in any way you can on your day-to-day. Just to start off, I dropped the link in the chat for the resources that we're going to be using throughout this presentation already. But if you want to follow along, or if you want like more info on what BIDS is, then you can just click that HackMD link in the chat, and that should have like all the resources and all the code that we go through the entire presentation. And if you want to follow along, there's data to download off the start. And also, I wanted to point out, if you have questions at any point, then please ask away. Just drop them in the chat and we'll get to them as soon as possible. And without further ado, let's get into the overview of what we're going to be going over. So first, we're just going to go over generally what the problems are with MR data management. Then we're going to go over an introduction to BIDS. Then I'm going to be going over why we need BIDS and how to convert your data into BIDS. This, by the way, is just for my part, the first part of the presentation. Alex also has a bunch more stuff to talk about data lad and BIDS apps and how to use them. This is just the first overview part on what BIDS is. So, data. This is the root of all problems here. We need neuroimaging data, obviously, for our analysis, but there's just so many different ways that it can go about being used. Neuroimaging data can be used. It can be of many forms. It can be in DICOMs or NIFTYs, or it can be directly from the scanner in a weird proprietary format. And it's always originally extracted from a scanner, but over the lifespan of the data, it's converted to other formats. It's QC'd, it's preprocessed, a bunch of stuff that can cause things to go wrong. And yeah, it's sometimes available via public data sets like OpenNeuro that we're going to be talking about later in the presentation. And I'm just going to go over some basics of the types of neuroimaging data if you're not familiar already. First, we have some anatomical data, T1 weighted or T2 weighted images. In a T1 weighted image, the white matter is white and the gray matter is gray, and it's commonly used to just like as a basic reference for the anatomy of the brain. Next, we have functional data or functional MRI. This tracks the blood oxygen level dependent or bold signal of the brain. And we also had diffusion or DWI data, which stands for diffusion weighted imaging, which is something I work with a lot. This measures the diffusion of water to model tissue microstructure. And we also needed to store info about the strength and diffusion gradient, and that's stored in BVAL and BFAC files. Before I move on, there's also a bunch more types of data like IEEG, EEG, and task event data. And there's just like so many different types that we need to organize and categorize for holding it for data preprocessing. I also want to talk about the concept of fair data. So a lot of times when we're talking about data management, we're talking about like what is good data and what is the best way of organizing data. So there's a set of data principles called FAIR data. It's an acronym on describing what is ideal for a data set. And the first principle is that the data should be findable. This sounds very basic, but it's like very important. The data and metadata should be easy to find for both humans and computers. Next is the data should be accessible. Users should know how the data should be accessed, whether there's like any authentication is required or they can just use it as is, and what is accessible in the data like per subject or per modality, whatever. Next, the data should be interoperable. I don't think I'm saying that word right as well at all, but like basically what the point of interoperable is that the data should be able to integrate with other data, and the data should be able to interoperate with other applications and workflows at any point. And also the data should be reusable. The data should be well described. It should have accurate and relevant attributes accessible to them. And also like at any point you should be able to click on like the JSONs or the describing files of the data set and get a good idea of what the data is. So these are principles that you should make sure your data complies to like at any point in its lifetime, whether it's like the base data or the downstream archives or the downstream derivatives. And keep this in mind for the rest of the presentation, because this is a good thing to come back to when asking what is good data. And if you want to find out more, then it's all on that link. That is also in the resources of the HackMD, so you can take a good look at like what fair data is, even outside of BIDS. So now that we have the basics of what data is out of the way, I want to go over why are we running into a bunch of issues with neuroimaging data. I will go over a couple of scenarios of why, or like pretty realistic scenarios for what we run into for neuroimaging data, and I want to know if you've ever run into anything similar like this, and why you can, or how we can avoid it. So first off, has this ever happened to you? Have you ever had to share data with a collaborator, but it's just completely unorganized, and you just look at the data and you're like, I can't share this with anyone. Like these are just like a bunch of diacoms. I have completely different names. I'm organized it in like an unorganized format, and the metadata is just like all over the place. And you're just like, God, this is just insufferable. I can't share this with anyone. I wish it was like in a standardized format that I could send whatever. Like, because even if you do try to organize it, maybe your organization method is not the same as theirs, and it's just going to be confusing either way. And also, has this ever happened to you where you had to collect basic info on a data set very quickly? You have like a collaborator asking for info on a data set and perhaps any downstream derivatives you created. And even if everything's run well and the data is all there, it might not be readily available and might not have any readable metadata for others to get a general idea of what's going on. And you just like, I wish there was like a good guideline for adding metadata to my data sets so I can pass it on to others. And also, has this ever happened to you where you had to run a pipeline on an unorganized data set? Like your PI or your coworker is telling you about some cool new pipelines like FMR prep or DMR prep or MRIQC, and you're like, we should run it on our data set. And you try to run these pipelines on your data set, and it's not recognizing any of the data that you have because it's extremely unorganized. And I wish all these pipelines like followed some specific format or something that we can easily pass in the data and run things quicker. Well, what if I told you that you can solve all these problems and more with BIDS, or the brain imaging data structure? It won't solve all the problems in the world, but it solves like a good deal with them, and I think it's really exciting and really cool. So an overview of what BIDS is, basically it's a standardized format to organize and annotate neuroimaging data. It's already been adopted by public repositories and multiple popular pre-processing pipelines, like FMR prep and MRIQC that I mentioned before. And the good thing about it is that it's very simple, and like once you see it and you haven't been using it, you're just like, why haven't I been using this the entire time? So let's get into what it looks like, because just that alone sounds really vague. There's just like so many different ways to organize data. So why should I be using this one instead? Other than the reason that it's everyone else is already using it, I can go over to the specific features of BIDS and tell you what it looks like, and you can see why it's so amazing. So first off, this is a comparison of a data set before and after BIDS version. Like right away, you should see like it looks a lot neater and readable, but I'll take a second and explain why this is. There's a naming convention that every file follows in some way. Every file needs to be following a sub ID, session ID, task ID, and run ID. Making sure that the files are named these with these few keys are key to the reason why BIDS looks so simple, because it already makes it a lot more readable. You can tell right away a file is like from a specific subject and a specific session and what the actual file is about. And that's just from the file name. Also, you can organize the data sets based off the type of data. So for example, per subject, there's anatomical, functional, and DWI folders. And this just organizes what you would think it is. All the anatomical data is all together, and all the functional data is all together, and all the DWI data is all together. And there's also other folders that you can add, like other data that are other neuroimaging data that complies with the BIDS standard, like EEG. This can also be added as a folder, and this is all under BIDS compliance, and it just makes it look a lot more neat. And if you want like a very specific subject and a very specific type of data, then you can look at that like right away. And now let's get into like metadata. There's also a dataset description.json at the very top level of the dataset. And this has basic information on what the dataset is. There are quite a few examples here of what you can implement. Like, for example, the required name and BIDS version and descriptions and acknowledgements. And basically, this just gives you a good overview of what the dataset is. And it's machine readable, and it's also human readable. And it's a good idea to like put that in your dataset. And BIDS just requires you to put the name and the BIDS version on it, but you can add as much as you like in this. There's also a participants.tsv that you can use for blacklisting participants as well as storing clinical data for others. This is useful for people who want to use the data sets down the line, but they need a general idea of how usable certain subjects are in the data set are. Finally, we have sidecar JSONs that are pretty much beside like every Nifty file, and these are generated by DCM to Next, so you don't have to worry about like filling it out on your own. But basically, it holds important data for the DICOM headers for the scan, and an important piece of metadata here is slice timing, which is used by pipelines like fMRI Prep for functional data. So this is not just like for people to read like on their own. This is also for pipelines to read down the line, so they don't have to like dig through like random DICOM headers and get like unorganized information. Instead, it's all in the JSON and all like corresponding to a specific data type. Now, that might seem like a lot, and you're wondering like, why should I go through all this? The reason is because it solves all the problems that I described and more. For example, the organization. Obviously, this data is like a lot more organized than just having a DICOM directory with just like misnamed subjects and misnamed sessions. And if you need to share the data with a collaborator or on a public repository like OpenNeuro, then if your data is in BIDS, then you're good. Just minimal name changing and organization lets you do like a bunch more stuff with the data. On top of this, there's also functionality. Standardized input means that you can have standardized pipelines and get standardized outputs. And by this, I mean, if your data is in BIDS, then you have unlocked a wide world of BIDS apps. Alex will go more in depth on why this is so great and why you should get started with running these. And just like a tease and a spoiler for Alex's part, it's super easy and it's super cool. On top of this, readability is like a lot better with using a BIDS data set. If your data is in BIDS, then you can rest easy knowing that anytime you need to look back at the data in 2 weeks or 2 years, you can get all the info instantly with the metadata, like the dataset description, sidecar JSONs, or participants.tsv. And there's a ton more benefits of using BIDS that I can't get to here, but like already you can see that this is a massive improvement over just using your data as is. And going back to FAIR data, you'll find that your data being in BIDS format matches FAIR data quite nicely and the principles of FAIR data. First off, findability. The data is findable by being in an organized format and with data metadata like dataset underscore description.json. Just this one JSON is just telling you a lot more information of what the data is and why you should use it, or like what the information is, what the data is gone from. On top of this, accessibility. Users, whether they're humans or computers, can easily access specific subjects using the naming convention of subject, session, task, and run ID. And also interoperability. Like I said, Alex will be going more in this in depth, but again, having the input in a standardized format like BIDS from the start can lead you to like using a bunch of BIDS apps and having more organized downstream. And on top of all this, reusability. Whether it's you looking back at your data later on or if it's being dumped on like a new grad student, metadata like the participants file allows the data to be reused for years after it's organized in BIDS format. So as you can see, BIDS format complies with FAIR data principles, which is amazing. 1 second, I'm going to take a drink. And now you're probably getting super excited about this and you want to know, how can I get onto this? Is it difficult? Like, what's the workflow? Like, how do I get my data into BIDS? Well, here's where I can talk about more why BIDS is the gift that keeps giving, is that you need like very little to no programming experience to convert your very own data into BIDS. All you need is very obviously data, whether it's like in DICOMs or NIFTIs or a proprietary format. Then you need DICOM to NIX or any other equivalent conversion software to convert the data itself into compressed NIFTIs. And a dream of frolicking, beautiful rolling hills and the prospect of all your problems being solved once your data is converted. Now, here's the actual steps for converting your stuff to BIDS. All you need is to create an output BIDS folder, basically the base folder where all your data is going to be organized in. And this can just be named BIDS for a specific data set. And then you need to convert all your data to compressed NIFTIs, like I mentioned, using DICOM to NIX or UDCOM for whatever compression software you want. And that is the reason we had to convert to compressed NIFTIs is for most MRI data that is the standardized data format or data extension to use for neuroimaging data in BIDS. And finally, you need to copy over and rename your files according to BIDS format. And that's basically it. It's very minimal programming if you do it this way. It sounds super simple because it is. Remember, BIDS is just like a way to organize data. So you only have to reorganize the data that you already have and you're pretty much done. Now, what do you do for the renaming? That part was like kind of left vague. You could like, do you have to just like rename it to a specific thing? Like, I know there's like anatomical and subject session ID, but I want more information on that. So that is all laid out on the official BIDS specification documentation page. The link is in the HackMD page that I linked earlier, but I think I could show you right now. Yeah, so this page, I think you guys can all see that. This just has all the documentation for what the current status of BIDS is and what the what you should be naming your files and how you should be organizing it. And it goes very in depth, but like also very comprehensively and minimally what the data should look like for every specific like modality. Like for anatomical data, there's like a bunch of pages on that. And for functional data and EEG data, if you have any questions about that, it's all on this page. And yeah, so that's like your Bible for looking at all the BIDS specification and the documentation. Now that might have lost a couple of you where you just don't want to look at documentation. I don't want to do any of this. To hell with BIDS. I'm just going to keep my data as is. But what if I told you there's like a much easier way to just refer to other data sets? Basically, you can just like look at other BIDS data sets and then get a good idea of what BIDS is, and then you'll pretty much get a good idea of like what you need to name your BIDS data sets to. So for example, OpenNeuro is a public repository where people all over the world have uploaded their data sets and they're approved for public access. And OpenNeuro requires you to upload your data in BIDS. So this means if you want to take a look at other data sets that are already in BIDS, they are currently at like 627 public data sets with like thousands of participants for reference. So if you want to take a look at other BIDS data sets, then they're all there. There's also an official Git repo that has BIDS examples that you can get a look at more minimal, but like a more comprehensive look of what BIDS looks like. It's literally what the repo says. It's BIDS examples. This is also linked in the HackMD if you want to take a look. And also, if you need to talk to someone about BIDS issues or anything else going on with your scientific journey, then Neurostars is a great public forum where you can ask other really smart people and really helpful people for advice. The final thing I want to go over for how to convert your data into BIDS is how do you validate your BIDS data set without having other people looking at it? Do you have to like just ask a BIDS expert every time if you want to make sure that your data is in BIDS? Well, the easy answer for that is that there's an official BIDS validator that's online on a website, and you can check your data it's in a proper BIDS format. I'll be going into this later in the workshop and showing you how to actually upload it. But it's very easy. It's just like clicking the file, choosing the folder that you have for BIDS, and then uploading it. And it will report back to you whether it's actually officially in BIDS and all the errors if it is not in BIDS. And note that this is not actually uploading the data anywhere. This is just checking the structure and metadata and telling you if it's correct or not. If you're paranoid, then you could just use BIDS validator as like a bash executable or a Docker container or in Python. And this is just a lot easier to use to make sure that your data is in BIDS. And I will also just show you that again in the workshop when I convert data in BIDS. And speaking of which, I will start that workshop right now. I will just show you very quickly how to BIDSify some data, basically using the tools that I taught you just now. Again, very minimal programming, and yeah, let's get started with that. Okay, so again, I have the HackMD link that has all my code in it if you want to take a look at that. So yeah, in the original HackMD, there's a link here for viewing the reference code, and also for downloading the data on a Google Drive link. And this is basically how to convert your data with very minimal programming, and I'll go over that right now. So once you have downloaded the data, as you can see, I have downloaded the SS 2019 Collabo data. Also,
So
this is
could
based
you
off
make
of.
that a bit bigger? Sorry.
Oh yeah, for sure.
There.
Is this better? Okay, yeah, sorry about that. So yeah, this is also based off of Aaron's code, which I also have linked in the HackMD. It's a very easy like tutorial for converting your data into BIDS. And so yeah, I'll just give everyone a second to take a look at the HackMD if they'd like, and also will stay hydrated. So yeah, now we can get started with the BIDS conversion. So, like I said, I have already downloaded the data. It's a TGZ file, and then I uncompressed it to Collabo data. And basically in Collabo data, it has a bunch of DICOMs that are, okay, my computer is dying because it's sharing too much, I think. Just give it a sec. Yeah, it has a bunch of data that's like basically the data that we've been describing before, where it's just like named like not very good things, and it's not in BIDS format. But we can easily change that. So first off, all we have to do, like I said, the first step is just to make a BIDS folder. And now you can see that we have the BIDS folder and our base data. And in that BIDS folder, let's start off with just doing subject 1. So first we just make subject 1. This is compliant with BIDS datasets because it's organized per folder by subject and then by session. So also, since we see that per subject, there's 2 sessions for the anatomical, for the functional and DWI data, then I'm going to make 2 folders for the 2 sessions for subject 1. So now, if we look at our BIDS folder, you can see that we have subject 1 and session 1 and session 2 for that subject. And now what I'm just going to do is basically run this little line of code that's in the HackMD, if you'd like, that just loops over. Oh, oops. I think I copied the wrong thing. Basically, it copies all the subjects for the rest, copies all the folders, or creates all the folders for the rest of the subjects. Yeah, it loops over the 9 subjects that we have, makes the directories for their session 1 and session 2. And once you do that, you can see there's all these subjects. And if you take a look at the tree folder, it has every subject and 2 sessions for every subject. Next, we're going to, now that the base structure is made, we want to make the anatomical data in BIDS format, because we see in the collabo data, in the base data, there are anatomical data files. But again, this is not in BIDS format. You can tell that it's session 1 to session 9. Subject 1 to subject 9. But we need to organize it in a better format that is BIDS compliant. So the way we do that is, I'm just going to copy this code. This line is basically making another directory under session 1 for subject 1, and it has the anat keyword. That just means that we're making a folder for anatomical data because we want to put anatomical data for subject 1 in session 1. So that is made, and then we just had to copy the data from. I just don't want to type all this out, so I'm just going to use this line of code. We're going to copy the anatomical data from the base folder, and we're going to copy it into a BIDS compliant folder and a BIDS compliant format. So you can see that this new anatomical data is named subject 1 in session 1, and it's T1 weighted. So you have to put this keyword at the end. There you can see that already we have anatomical data in BIDS format for subject 1 and session 1. I don't want to look at all the. So we're missing it for the rest of the subjects, but for the first subject, we have the anatomical data in BIDS format. But we could just pretty much just make a loop. Again, this is very minimal programming. I'll explain what this script or what this loop does. It basically just does what I did for subject 1, but for all the other subjects in the base data set. It loops over the other 9 subjects, and it copies the data from the base data in its original format and its original name, and it copies it to the anatomical folder of that subject's anatomical folder. And I'm not sure if, okay, yeah. So now if we look at the BIDS folder again, you can see all the anatomical data is there for every single subject. And this is basically all in BIDS format already. The way we can check that, or there's one other thing that we're missing, but first I'm going to take a look at the BIDS validator. One sec. Okay, yeah. So now that we have a data that we built, a data set that we built using BIDS, we can use the BIDS validator to check that if it's BIDS or not. I'm going to check this ignore nifty headers because the data is not fully complete, and I don't want errors to be checked for that. But basically, I just had to upload the BIDS folder I've created. And again, this data is not being actually uploaded to the data set, to the website. It's just being checked and it's dumped away. It's not like being stored anywhere. So you can upload your private data sets and it's completely fine. Or you can just use like the command line interface or Python or Docker if you'd like. As you can see, I've already had one error. Like I mentioned, there's one other thing that we're missing. The dataset description is missing. You need to have a mandatory dataset description, just like with a very few fields that we'll create in a sec, to just describe what the data is. But the rest of the data is fine. It's there's a warning for also readme file, which we'll also create. But the rest of the data is fine. Like it's all being named BIDS format and it's all organized in BIDS format. So now the final thing that we'll do is to make it fully compliant with BIDS, we will make a dataset description and README. So first, for the README, I'll go into the BIDS folder, and I will just make a basic README. And again, this is all in the HackMD I linked. And I'm just gonna put this like throwaway data to make the BIDS validator happy that there is a README in the file. If you're making your own data set, obviously you're gonna put like a lot more information and a lot more detailed information on what the data is. But for now, we'll just create that. So if you want to take a look at the README to make sure that it's there, then you can see it's all there and the README is created. And the other issue that the validator was complaining about was the dataset description. So let's create that as well. And again, I'm just going to copy this base data. And as you can see, I've labeled the BIDS version that we've been using so that the BIDS validator knows which BIDS version there is. The reason there's different BIDS version is that the community of BIDS changes BIDS depending on what the community needs. There's still like, it hasn't been changed like that much, like the basics are the same, but like if there's any like new data types or a new like field that we want in a JSON, then we have it all, like we have the ability to change BIDS if it's like a community thing. We also have the name of the data set and the authors. And this is like the minimal information that you need in the dataset description to like make sure that it is BIDS compliant. So we're going to save that as well. And again, we'll just check that it's saved properly. Okay, cool. So we have the dataset description of that JSON and the README for all the subjects and all the subjects data all in BIDS format. So again, if we go back to the BIDS validator and we just upload the data again to check if it's BIDS compliant. You can see that it's now completely fine and there's no errors, so it means it's BIDS compliant, and you could upload it to any like OpenNeuro, or you can share it with collaborators, and it's completely fine. The only warning here is, oh yeah, the README file is too small. So again, like I mentioned, the README, you would want to put like detailed information and a lot of information, as information as possible to describe the data set, and it's just like a good practice in general. But again, it's not breaking the BIDS compliance at all. Like again, this was a warning before where you don't actually need the README. Another point of BIDS is that it needs to be like very easy to convert into BIDS, and you don't need to like put in incessant information or like unneeded information. So they don't complain about like not having all these specific fields and all these specific files uploaded to your data set. So yeah, I think that's pretty much all that is for the workshop. I do have like other bonus like copy over code that you can also play around with yourself. But I think I got the point across with the anatomical data. And it's basically just like copying over the data and making sure that it's like all named properly, and that way all your BIDS is all your data set is in BIDS. And again, it takes like very minimal programming. It's very easy to do. And now that we've done that, I'm going to go back to the presentation real quick to wrap up my part. Okay, cool. So now that we've BIDSified the data, I want to say that the cherry on top of all this is that there are other tools out there available that make this a lot more easy. For example, DCM to BIDS is a Python package that allows you to specify where you want all your data to be organized with a JSON. And basically, this JSON is the mapping between DICOM metadata and what you want to be organized as in BIDS. And then with the DICOM directory and the JSON, DCM to BIDS will convert all your data using DCM to NIX, deface it if you like, and move and rename the files to a BIDS compliant output. and it's like super convenient. If you want to like streamline all this process, it's a lot easier if you just use a tool like DCM to BIDS, and that way you don't have to like write your own code for getting into the nitty gritty of copying every single folder and deciding if a specific subject is like named improperly and you have to like change the code to rename it. This will read directly from the DICOM headers and then use the JSON to map it to a proper BIDS file output, and the BIDS output will always be BIDS compliant. And so yeah, I just went into the process of doing that, just like so you know what BIDS, like what the minimal necessities of BIDS minimal necessities of copying over to BIDS is. But again, on the day-to-day, I don't actually copy over the data one by one. I use something like DCM to BIDS to streamline all the stuff for me. And yeah, that's basically my part. I want to conclude my part by wrapping up and saying one thing. BIDS is the future of neuroimaging data, and there's a million reasons to start using it in your life. And that's pretty much all I want you to take away from my first part. I will end it off there. We are going to give you guys a 10-minute break to digest all that, get coffee or water, and then we will resume with Alex's part on BIDS apps, which is also extremely cool. Like once you have all this BIDS stuff out of the way, you can get into some pretty crazy stuff with BIDS apps. So yeah, we'll take a 10-minute break and we'll resume at 4:22. Oh wait, Alex, I think you're muted, or you
I
can
was
hear that.
I was 100% muted. Thank you. I was just saying, if people have any questions at this point, it's a good time to put them in the chat, and we can answer them right when we resume before going into the working with BIDS data part. And with that, I'm going to go get some water. Okay, everybody, we're going to get started here in a little under a minute. So I hope you grabbed your coffee and we can push through to the end of the day. So first of all, I just want to thank Aaron particularly, but everyone at BrainHack broadly for doing a lot of the legwork, most of the legwork to put this together. It's a lot of hard work. So we really appreciate all of that. In addition, I want to thank all the people that presented today, all the talks and the discussion panel, not just for all the excellent presentations and dialogue, but frankly, you've done a lot of the legwork for me today. This presentation, a lot of the tools that have come up in previous presentations you're going to see in this part of it. A lot of in Jacob's talk, all the pre-processing he talked about, you're going to get to preview a lot of that. And then a lot of the issues the panelists talked about in managing data and good workflow practices are hopefully, if not solved, at least ameliorated by the things you'll see here. So hopefully this provides a nice tie together and a nice coda to the day. And with that, I'm going to get started on the last section. So in this section, we're going to be seeing how we actually work with BIDS data sets. So you've converted your BIDS data set or you've gotten one, and we're going to see what you can do with it. First, I'm going to give a brief interlude to go more in depth about OpenNeuro and DataLad. You've probably heard these things come up today, and I'm just going to really flesh them out because they're a great resource for you as a studious graduate trainee who's looking to wet their teeth with these tools. So OpenNeuro is, as it says, a free open platform for analyzing and sharing neuroimaging data. It's got about 627 open neuroimaging data sets, so anyone can go and just download them. You don't need an account. You don't need any credentials. You can just go and download them. It's completely free. You don't need to know what you're doing. You can just grab them. It's absolutely wonderful. This is the link. It's also in the HackMD document. You can get it there. And pretty much you go to the website and look, it tells you all these people. You can search by modality. You can search by keyword. And when you do, you just get a ton of data sets that come up. This one was searched by, I was searching for MRI, but you can change it if you want. I'm going to kind of whip through this slide, but essentially the important details are it tells you a bunch of metadata about the studies. It tells you, information about how many sessions, participants, importantly, the size of the data set. Keep that in mind. Make sure you're not downloading these massive data sets by accident. And then additionally, you can do a lot more filtering on metadata. You'll be able to search by number of participants. You can filter by age if you're interested just in, adolescent development. You can filter by PI. Say there's a lab, someone from a lab that you met at a conference and you're interested in some of the stuff they've done. You can filter by their data sets, et cetera, et cetera. And obviously some other sorting. Once you click a study, you're going to come to this landing page, which just kind of fleshes out the metadata and gives you a brief kind of overview of the BIDS data set so you can actually see what's in it. But the most important thing here is the clone button. Now, if you remember from the Git talk, this looks a lot like cloning a Git repo, and that's because it's pretty similar. So the best way to get, well, maybe not the best way, but one of the best ways to get these OpenNeuro datasets is to use this Git URL and DataLad. So you've heard a lot about version management for your software, but part of fair data practice is also we want to have something like that for our actual data sets. We want to know what was done to a data set when, and we want to, because, as these people mentioned, as the panelists mentioned, a lot of times you have a data set, you do some work on it, and then you go talk to your boss and they say, could you maybe tweak this thing a bit? And you go, okay. And, you're thinking, now I've got to have two separate ones. No. You can use versioning to maintain these data sets in a way that's essentially just Git. DataLad's just built on top of Git and Git Annex. So it's a really great tool. And I'm not going to go into too much detail about it here, but I encourage all the young trainees to start getting acquainted with it now. The earlier, the better. And the more you get used to it, the more you can use all its wonderful features. So I'm just showing an example here of how easy it is to get a DataLad data set. So I chose an OpenNeuro one, and I just hit DataLad clone. And it's a big data set, so it's taking a while, but it won't take that long, because essentially what it's downloading is just kind of the skeleton of the data set. It's not actually downloading all the data. So you see now I just have all these subjects in my directory. And I'm going to go into one of them and just show you what it looks like, though. So as I said, it downloads the kind of skeleton of the data. The important part is, especially for these big Nifty files, they point to, that's just how you download. They're not actually downloading the file themselves yet. They're pointing to this get annex object, which is more a way to tell your computer to get the files. The reason I mention that is because then when you actually want to do analyses, which we're going to do subsequently, you first have to use the datalad get command. You can kind of think of it as a git pull. So here what I'm doing is just showing you, if I want to try and interact with these images before using datalad get, it's not going to work, right? So I'll put in the path to the data, because I'm thinking, I want to look at this anatomical image for subject 11, I suppose. So I put in the Nifty image. I've got my data set. I think I'm good. Oh, but no file exists, right? It's complaining to me. And that's because I didn't do datalad get. So first things first, you just have to go datalad get. And the way this works is you can either give it a path to a specific file, and it will grab that file. You can give it a path to a directory, and it will branch down into the directory to get all the files in there. So in this case, I just gave it the anat directory, and I'm getting all the files there. If there's more than one, it will grab those. And now I'll just show you that I can interact with it. So this is just important to know when you first start using these tools. I don't want you to be confused. I thought I downloaded the data set. Why can I not do stuff with it yet? It's more convenient this way, because you don't have to worry about if you just want to see the anatomical images from a really big data set, you don't have to download terabytes of data. You can instead just download these. But yeah, that's just a brief introduction to datalad. These are just some of the commands, and importantly, this is the documentation. So I encourage you to go there, start using it, because that's how I've been downloading all the data sets for this tutorial. If you want to follow along, as you've seen in the HackMD, that would be the way I would recommend it. But also, it's just good practice. So now we're going to talk about BIDS. So you have your BIDS data set from OpenNeuro or your own that you've made, and now you want to do analysis on it. Now you could write your own scripts to kind of take in all the metadata and digest it and navigate, or you can just use what people have done already, which is a much better option. This has been something that the community uses. It's been tested, vetted. So PyBids is just a Python package you can install with an easy pip command, or with a conda command as well, whatever Python environment manager you're using. And I'm just going to give a brief overview here. So the main object is the PyBids BIDS layout class. So essentially, you just pass to this class the root of your BIDS directory, and it will give you an object that you can then search for all the BIDS metadata you want to get all the files, the file paths. It's very useful. I'm going to show you an example here. So I go into my Python environment. Just as a brief aside, Python packages, 9 out of 10 of them, the PyPy name is the same as the package name when you actually import it, but PyBids is one where it's not. So the installation with PyPy is PyBids, but then in Python, you import it using BIDS right here. Anywho, so I get the BIDS layout object, and now I'm just going to give it that data set I downloaded, the path to it. Now it's going to construct this class that will allow me to query my BIDS data in a really convenient way. This was a big data set, so it takes a while to navigate the full tree, but not too long. Longer than I thought. And if you're following along, you can try this with a data set you have. Then you see I run the layout.get method, and it just returns a ton of objects to me, everything in this BIDS data set. So I'm going to highlight a couple of them. You see there are all these PyBids classes that give you the file name. It's a big list of all of them. And there's a couple important ones to note. There's the BIDS data file class. So this is going to be for all of your kind of secondary information. So you see this one's the scans.tsv. Any kind of information, the confounds file that you have, any extra information that's not in the in a JSON or a Nifty image will pretty much be a BIDS data file. The BIDS JSON file, so these are the JSON sidecars with all the metadata, and probably the one you'll interact with the most, the BIDS image file. So this will be pointing to an actual Nifty image. And then the last one here, you'll notice this BIDS file name. So this is kind of the catch-all class. Sometimes it doesn't know what to do with, for example, this is a B-value file. Alternatively, PyBids isn't quite fully fleshed out for all the EEG data, so I believe EEG files are loaded as just normal BIDS files. Now, all these different classes have their own methods that you can interact with. I'll link to the documentation. I encourage you to just explore it, but I'll show a few examples. Actually, now I'm changing keys. So obviously, if you just use get, it just returns everything. But often you don't just want everything in your BIDS data set. Often you're going to want to filter. You're only going to want certain types of images, or you're going to want all the second session diffusion images because you know these are new and we haven't run the analysis. So you can pass keywords to the get command to search through the BIDS data set. So in this example, I'm passing the suffix keyword. So that's the very last part of the BIDS file before the extension. So for example, this one, T1 weighted, I'm going to get all the T1 weighted anatomical. But if you put DWI, you would get that. And I also put the extension keyword to get only the Nifties, because otherwise it will also return the JSONs. So using that command, that get, here, we'll see the command one more time maybe. Or no, it'll probably take a while. But using that, I can just filter. Oh, yeah, so this is further looking for the commands. Another thing I can get is all the files just by subject, right? So now it returns all the func, all the ANAT files as well. It will return the JSON sidecars. You can also obviously get it by multiple subjects. This time I'm looking once again for the T1s. It's just convenient to do, the Nifties. And then this is a really important one too, the return type flag. This will specify whether you get the PyBids objects or you just get file paths. When I say file, I just get the file path. Next, I'm using this layout.getMetadata on this specific subject. So I pass it the path to this first subject in my targets, and it returns all the metadata associated with that subject. So once I have my layout and I've returned the path to my subject that I've searched on this layout, I can get any information. So now I'm passing a different subject. It will just pop up all the metadata for that specific subject and file. This is a great way to quickly search metadata, like if you suspect a subject, something's different, et cetera, et cetera. It's really convenient. And then this is the last feature I want to show you about PyBids. It's the reports. It's my favorite feature. So you've done your analysis, you're presenting your poster, or you're writing your paper, and you need to write up your method section, but you're not an MR physicist. And you're like, what exactly do I need to put in? What parameters are important for all these different scan types we have? PyBids reports can do that for you. So once again, I'm just getting these specific subjects because I'm only going to get the report for a few of them instead of on the whole data set. Is this still the get metadata? Why isn't it? Oh no, I might have put the wrong GIF in, ladies and gentlemen. The actual class is, this is the wrong GIF. The actual class you use, I'm going to switch screens to just show you on the fly. You import the class using you have to import from the PyBids reports folder. So will this take a while? Hopefully not. I wanted to make all the GIFs on the so I wouldn't have to do anything on the fly, but still have to do that. So I got my terminal. Okay, I'm just going to activate an environment to show you. Go into IPython. So the command you would use to get the BIDS report is from BIDS. This is really small. I can't zoom in right. There we go. From BIDS, BIDS.reports, import BIDS report. So it has a similar syntax to the BIDS layout, but you have to go into the .reports class. And then you have to pass it. So right now, this isn't going to work because I don't have a layout, but the BIDS layout object we made previously to get the report, you pass it to the report object. So you give it that layout we made earlier, and it will create a report object. This will just fail because it will say I don't have a report. I'll go back to the slides. And then using that report, you can generate, you use the report.generate to generate these texts of the, you can see how this is for session none, well, because I only had one session for the sample, but MRI data was acquired using a 3 Tesla Siemens Prisma MRI scanner. It gives you all the echo time, the flip angle, all that stuff that goes into your posters or your papers that sometimes when you're not as close to the scanner as the techs or the physicists, you're not as familiar with. So this is a great way to get those there. You can just print them out and dump them into your report. Instant method second, exactly. So I'm just going to give a quick summary about that because I really want to get to fMRI prep for the last part. So yeah, try using PyBids if you're writing your own kind of tools to navigate your BIDS data sets. As I mentioned, remember the PyPy name and the package name in Python are different. It's one of those special ones, so remember to use the import BIDS. The main class you're going to interact with is the BIDS layout, and then practice filtering the metadata. See what kind of files you can get. The more you work with it, the more comfortable you'll get. And then this link is also in the markdown we provided, but this is just a great notebook tutorial on using PyBids with a bit more detail than I've given today. So now we get to the big part, the big one, the BIDS apps, what this has all been about. As Aaron mentioned earlier, this was kind of this is the best part about BIDS. This is the thing, you know, having BIDS is great to share data sets, but the thing that's really tough to standardize are the analyses. Every lab has slightly different analyses with slightly different things, and rerunning the same one that they did can be difficult. It's not as easy as it should be, even though you have the same data set. And hopefully BIDS apps solve this, or at least make it easier. So part of this, I'm tying back to the FAIR principles, but the BIDS apps really help with this, especially, you know, with having the data be reproducible. Someone ran a BIDS apps on their BIDS data sets. You can get that BIDS data set and that BIDS app and run the exact same analysis. It's really wonderful. I think if you haven't experienced the world before the BIDS apps, I hope you never have to. So I'll just briefly mention Docker because this is generally how people use BIDS apps. Docker is just a containerization service. If you aren't familiar with it, it essentially bundles all the dependencies you need to run the application into kind of a single container that is isolated on your system. So it makes sure that each time you run it, you're running it with the exact same dependencies, and you don't need to worry about installing all these other dependencies that you usually do, which version, et cetera, et cetera. Essentially allows you to reproduce the pipeline exactly. So this is the way I recommend when you're starting with BIDS apps to be using them. In the markdown, we linked to a Docker installation and just a brief rundown, though I will go through the commands in more detail. This just shows kind of what Docker is. You know, on your side, you're just running really simple like Docker run commands. It makes these containers. And then importantly, there's this thing called Docker Hub, which is kind of like GitHub, but for these Docker containers where you don't have to go and find the Docker container. You can just tell Docker, pull this one that someone used from Docker Hub. It's very convenient. So I just gave that because we're going to be using that to run fMRI prep. So you've heard a lot about fMRI prep today for good reason. It's a wonderful, wonderful, wonderful BIDS app to use. What it does is it sort of does the minimum amount of processing that you would want to do in almost every scenario. So it does things, Jacob mentioned most of them. It does things like slice timing correction. It will do the distortion correction for you. It does registrations to standard space. It extracts the brain. It will do segmentation using FSL or with FreeSurfer as well. So it does the sort of things that everyone does that you would pretty much do anyways, but it also does them in the same way. So instead of worrying about tweaking the little things, which can lead to differences in outcomes, it will always be the same. Additionally, it provides a lot of QA and QC metrics for you. Provides report documents that you can scan over to see what the quality of your data is. And then finally, it estimates confounds. Jacob mentioned running GLMs on your fMRI data. And often you don't just include your stimulus of interest, you also include confounds like motion or activity in the CSF or something. And it will provide these, it automatically extracts those time series. So if you plan on doing those further analyses, you can. So this is where we get to how you'd run it. If you're doing it with Docker, in general, the Docker command to first pull an image from Docker Hub to your machine is Docker pull, and then you give it this Docker Hub root, the container, and then importantly, the version. You want to always make sure you're giving the version. You can just type in latest, but then you might not know what version you're running, so always give it a specified version. And then to run the container, you just do Docker run, and you give it that container that you've just pulled, and then you pass the arguments. So in the case of fMRI prep, this is kind of the basic command you would run. So Docker run this -ti, you should put it, it just allows you to Docker to interact with your shell, because you'll probably be running this in a bash shell. This --re means that Docker will automatically shut down when it's done, which is good. You want it to do that. The -vs are how you mount things to Docker. So when the Docker container is there, it doesn't know about files on your local system. So you want to give it the path to your BIDS file that you'll be running. And the standard is you just call it /data, right? This is kind of how Docker will recognize that it's /data for everything. You also give it the output. For BIDS, what we generally do is you do the BIDS folder and then you do /derivatives. That's the standard. There's a whole extension of BIDS to pre-processing derivatives that you should use. Finally, also, I give it a working directory. So fMRI prep can take a really long time to run, especially the FreeSurfer, and it might crash at certain times, or maybe if you're running it on a cluster, you don't get enough time, compute time, and it shuts down automatically. If you give it a working directory, that means you can resume. Next time you come back, you see it crashed, you can resume where you were by passing the working directory again, and fMRI prep will go through, see what's already been run, and then pick up from where you left off. So instead of going, oh no, I lost all my work, I got to start, run another 48-hour pipeline. Nope, you can just start from where it was. Then, as I said, you pass it the container, the Docker container that we pulled. So in this case, I pull from NIPREPs, fMRI prep, and then the version, I think the version I used was 21.0.6 or something, but that's unimportant. And then in general, you pass it where the BIDSDER is, where you want the data to be. So this derivatives folder. And then the BID standard, you're doing this at the participant level. This just means you're analyzing per participant. You can analyze per group as well. You can look into that in the BIDS documentation, but for fMRI prep, always at participant. And I encourage you to go to this documentation to see more. So now I'm just going to show you what the output looks like, because if you were trying to run this in this tutorial, it definitely wouldn't complete in time. So after you run it, there's going to be a subfolder for fMRI prep. This is where kind of the pre-processing is and some of the confounds will be. There'll also be a subfolder for FreeSurfer, where all the FreeSurfer segmentations and parcellations are. I didn't run FreeSurfer when I ran this because I didn't want to run it for too long. I was just trying to create an example. So I won't show you that, but I'll show you everything that's in the fMRI prep. So first of all, for every subject you run, there's going to be this .html. And this is going to be a general report page where you can see a summary of fMRI prep. So I'm going to show you an example here. So this is the summary report from the one I did. I believe also in the document, they have an example summary that you can go through on your own. But you see it just gives metadata about the BIDS, gives metadata about the anatomical, and it shows you visual quality stuff. You can see just kind of at a glance how the segmentation was, how the brain mask looks. You can see how the registration went. So it gives a nice little GIF. Ooh, fancy. Looks like a pretty good registration to MNI space. What else do we have here? This is the alignment of the functional to the anatomical data, another thing that's very important, as we've mentioned. And then it starts to go into some of the QC metrics. These, you can read more on them on the fMRI prep documentation. Also, you should ask people in your lab which ones are important. Something like this, the frame-wise displacement. You see these spikes in the data clearly. This means there was probably the participant moved a bit right at this point. You can even see it in the raw data a bit, I think. But these kind of give you a thing, if you're seeing a lot of spikes in your frame rise displacement, that means there's a lot of motion just at a glance, probably not so good. These are the nuisance regressors that I mentioned that it automatically extracts. Gives you all this data. And then it also gives you, I was talking about getting auto-generated method sections. You also have that here. If you want to use fMRI prep and you want to put that in a paper, here is the auto-generated text for it. And you can get it in LaTeX, you can get it in Markdown, however you need it. It's incredibly useful to give you a way to just kind of examine your data and see the quality of all these pipelines. So this is the sample report, if you want to check it out on your own, that they have. And then I'm just going to explain what fMRI prep actually outputs. So within, there was those subjects.html files, that's the report. But then there's also a folder per subject that you've run it on. And within that folder, there's the classic BIDS things that you've come to get used to. There's an ANAT subfolder and a func subfolder. So in the ANAT subfolder, we got a lot of stuff, but it's not bad, I promise. So this tag in BIDS, DESC, it stands for description. It's kind of a catch-all tag to put, especially for derivative data, to explain to you what it is. So in this case, desk brain underscore mask. I think all of you can figure out that that's the brain mask. It does. It provides a brain mask for you. Desk pre-proc T1 weighted. So this will be the pre-processed T1 file. So this is the, I think, brain extracted normalized MNI space file. It also gives segmentation information. It gives the actual transforms, these XSM files, the matrices for the actual transform. Here it gives the probabilistic segmentation for the different types of brain structures, the white matter, the gray matter, the CSF. And then these are all the actual transform nifties. And then each of these files has a JSON. So it's a lot. It looks like a lot of output, but it's just kind of standard stuff that you'd have. Oh, I should mention the space tag tells you what space, what standard space this transform is. So this one, MNI 152, it's a pretty standard one you've heard about already today. And then the func data. So similarly, it gives you a bold reference images. This is a average of the bold that you use sometimes for registration. It gives you a brain mask as well, and then it gives you the pre-processed bold. This is probably the most important. It's in MNI space, and it's been pre-processed. So this will be the slice timing corrected image. It will, what other things does fMRI prep do on the bold images? Oh, the susceptibility correction that we've already talked about. It also, I think, does ICA denoising, which you briefly heard about at the end of Jacob's talk. At least if you run the full pipeline, in the documentation, you can see the flags to specify just running certain steps or ignoring others. In this case, I just ran everything. So that's what that would have. And I encourage you to, once again, always go to the documentation. This talk isn't nearly long enough to really go into too much depth, but the resources are there. You can read on them. And also people, all the colleagues you work with probably have experience with this as well. So feel free to ask away. Lastly, I'm just going to mention MRI QC, which has also come up today. So MRI QC is a pipeline focused on just generating some quantitative QC metrics for your structural, your anatomical images, and your bold images. It doesn't do the pre-processing that fMRI prep does, but also because it's not doing all these segmentations, it runs a lot faster. So it's a good way to get a really quick look at if your data is up to snuff. Once again, there's a ton of measures it outputs. I'm not going to go into too many of them. I'm mostly just going to show you what it does. And hopefully if you've been following along, if you ran the command and it worked at the beginning of the break, you might have your own MRI QC folder you can go through. So this is the Docker command to run it. You'll notice it's almost identical to the fMRI prep command. And this is the great thing of BIDS apps. They have a very standard input output. So similarly, we mount our BIDS dir, we mount our output dir, we create a working dir, and then we just call the image, the Docker image that we want the MRI QC in the version. And then once again, we're doing this at the participant level. You can also do it at the group level if you want, but I'm only working with one participant, so there are no groups. And then once again, in our derivatives, this is what the file tree is going to look like. You'll notice it's a lot simpler. There's no nifty files, as I said, because it's not doing that pre-processing. All it does is generate a report, an HTML, for each anatomical and bold image you had, as well as these JSONs. So the JSONs just contain a quick list of all the IQM metrics, the quantitative metrics that you had for each file. So this is what's great about MRI QC is it's faster to run, and then these JSONs are quick to search. You can just grab them and quickly load that data. So you can really quickly get some quantitative metrics to report back to your PI about how the data is looking. I'm actually just going to quickly show you an example of it as well. If you have your own, that is great. But if not, so this is what the MRI QC reports look like. So importantly here, there's also a rater scale here. You can rate this information. I can't remember where it gets put back to. I think it just gets put back into the subject folder. And you can flag it as you want in the JSON. So this is really useful if people are doing, you have students doing visual QA on the data, which, you should be doing at least for some of it, at least when you're auditing. But I'm going to close that because I'm not rating, I'm just showing you. So once again, it gives you visual summary so you can just inspect for your own MRI artifacts. But this is, an open neuro data set of 1, so it's pretty clean, not noticing any artifacts. And it's, this is the noise, so just the background noise in the structural image. You'll see, if you remember from the talk, we have some noise, higher noise in the higher susceptibility areas down kind of where the eyes are. And then, at the back of the head, there's often some noise, but otherwise, this looks pretty normal. This looks like a good quality scan. And then importantly, this is just a list of all the image quality metrics. Now, I remember MRI QC once putting out nice, pretty graphs of these, not just these, but I think that is only for the group level. So because I only ran one subject, it's just going to be the list of all of them. But when you run it at the group level, you get these really nice graphs that pop up. But these are these values. There's a lot of them. If you're a new trainee, it might be a bit intimidating. But just talk with your PI, other people in your lab, find out what they think are the most important ones, or even just as you get to know data, you might get to know your data set, and you'll know what seems to be an important flag, maybe for in the past, the scanner had an issue, and this was the metric that alerted people to it. So maybe you're monitoring that. There's a lot of them. It's very thorough. You probably won't use all of them, but it's there. Additionally, because this data set had bold, there's also it provides the reports for the bold images, but they're mostly the same. It provides, the average standard image, the noise in the image, or in this case, the standard deviation, but it has similar things. There's more noise in the brainstem, kind of the high susceptibility areas and near the top of the head. And then it gives you a plot of some of the same metrics we saw with fMRI prep. Though in this case, you can see it's mostly just related to the motion, right? The framewise displacement, the DVARs, and you can see here, similar to what fMRI prep told us, there was clearly some sort of movement spike at this point. And that's good. That means these pipelines are telling us the same information. That's what we want. And then there's just a third one, but I won't go into that. It's just another bold. It's the same thing. And these are pretty good quality, so it doesn't matter. So we're just running out of time, so I'm just going to bring us to the finish line. So in conclusion, BIDS is good. I hope that's the one thing you take away today, if anything. Fair data principles are good. We want our data to be easy for other people to use and reproducible. And finally, BIDS apps, I should have put great. BIDS apps are really useful. They make the first parts of your analysis so much easier, and they let it so that other people can run the same analyses as you. Things that are bad, data chaos. Don't just organize your data anyway. These kind of bespoke random naming conventions that you might have seen where people run an analysis 5 different times and they don't really knew it. This is what data lab's for. Don't do that. That's bad. And this is a bit tongue-in-cheek, but if you can, use a BIDS app first. You won't always be able to do that. Then you develop your own, but go for the BIDS app first. So there's the side of the angels and the devils, and I hope I know which side you'll end up on after this presentation. So thanks for joining us for this. I hope it's been helpful. And if you have any questions, now would be a great time.
Yay! Gotta give you lots of claps for that. So many claps.
This is like out of the scope of the presentation, but like to pile on to like the BIDS apps appreciation, fMRI prep and DRMI prep and MRQC, they're also open source. They run on this thing called NiPipe, which is a framework in Python. It's like also a very easy thing to get into if you want to start working with it. So on top of it being like cool BIDS app stuff, it's just like a really good open source pipeline to work with as well.
I completely agree. Yeah, I didn't even get into the NiPi workflows. That can be really great if you were making your own workflows because you wanted to make your own BIDS app. But I mean, that's a whole other world. And hopefully any of the trainees are inspired and will look into these tools and start using them themselves.
Yay. Can't recommend enough. Yes, I don't know if we have any questions coming or just applause. So much applause. It's getting late in the day.
Yeah.
Yeah.
It's been a long day for these folks.
It's been a long day. But yeah, replay will be available. You guys will be around on Discord. And actually on Mattermost, you may be able to find one of the cool developers who wrote these BIDS apps, even lurking and answering questions. They really do exist. They're real people. And they exist in the BrainHack community, and you can meet them in real life or talk to them on Neurostars. So beyond this, so this is the end of the day. I think everyone's getting a little tired, but after dinner, we'll come back and play Among Us because Among Us is so fun. And Salim will kill you, and my child wants to kill you virtually in Among Us as well. So yes, come back and play with us, and we will be project pitching tomorrow morning as well. It'll be super fun.
Yeah. Again, thanks, Aaron, for organizing this, and thanks for having us, and thanks for everyone for joining.
Yay.
Yes, thank you very much, Aaron. We hope you all found this useful, and we'll see you in the future.
Super useful. I think this will be referred to many, many times in the future. So, yeah. Bye, guys.
Bye, everyone.